From being uninhabitable for life because of its hellishly hot surface, to a theory that its thick yellow clouds could potentially harbor microbes, we've slowly unearthed a lot about our planetary neighbor. But Venus still has a lot more in store for us. NASA has revealed that its squishy outer shell is resurfacing. This discovery comes from the use of archival data and could potentially give insight into how the planet's heat is being dissipated. So, what does this mean for our understanding of Venus? Firstly, the research team's findings show that Venus may be losing heat from geologic activity in regions called coronae, possibly like early tectonic activity on Earth. These coronae are circular features on the planet's surface that are thought to have been caused by upwelling mantle material. Earth and Venus are both rocky planets of about the same size and rock chemistry. As a result, they should be losing internal heat at roughly the same rate. But while Earth's heat flow mechanism is well known, Venus's mechanism has been a mystery to scientists forever. And this is where the study comes in. Using data from the Magellan spacecraft's observations from the 90s, the research team analyzed quasi-circular geological features on Venus. They made new measurements of the coronae visible in the Magellan images and concluded that they tend to be located where the planet's lithosphere is at its thinnest and most active. This is exciting news because it could mean that Venus's heat flow mechanism is similar to early tectonic activity on Earth. But wait, what exactly is a lithosphere? Well, the lithosphere is made up of the crust and the uppermost part of the mantle. It is divided into tectonic plates that move and interact with each other. Earth's tectonic plates move due to the heat from the planet's core, which causes convection currents in the mantle. These currents move the tectonic plates around, creating geological features such as mountains and earthquakes. Now let's get back to Venus. Suzanne Smrekar, a senior research scientist at NASA, led a study published in Nature Geoscience that challenges the long-held idea that Venus's lithosphere is stagnant and thick. The new view is that the lithosphere is evolving and becoming thinner, which allows more heat to escape from the planet's interior. This is because a thin lithosphere lets out more heat through buoyant plumes of molten rock that rise to the outer layer. Areas with enhanced heat flow typically have increased volcanic activity below the surface. So what that essentially means is that the coronae are to likely reveal locations where active geology is shaping Venus's surface today. The researchers examined 65 previously unstudied coronae that are up to a few hundred miles across, and that is how they were able to calculate the thickness of the lithosphere surrounding them. They measured the depth of the trenches and ridges around each corona, where they found ridges that are spaced more closely together in areas where the lithosphere is more flexible or elastic. They discovered that on average, the lithosphere around each corona is roughly 11 kilometers thick. They found this by using a computer model of how an elastic lithosphere bends, and that is much thinner than previous studies suggest. As the predicted heat flow in these areas is higher than the norm for the Earth, the coronae may be geologically active. Smrekar stated that although Venus does not have Earth-style tectonics, similar to the zones where new tectonic plates emerge on the seabed of Earth, the thin lithosphere regions appear to be permitting a considerable amount of heat to escape. This is important because it gives us a better understanding of how Venus is dissipating its internal heat. If Venus does indeed have a mechanism similar to early tectonic activity on Earth, it means that the planet's interior is still active and undergoing geological processes. This is surprising because Venus is often thought of as a dead planet due to its harsh and uninhabitable conditions. But what does all this mean for us on Earth? Well, understanding how Venus dissipates its internal heat could potentially give us insight into the future of our own planet. Earth's tectonic activity plays a crucial role in regulating the planet's climate and maintaining its habitability. If we can better understand how Venus's tectonic activity works, we may be able to apply that knowledge to our own planet and learn how to mitigate the effects of climate change. Venus has a thick atmosphere that is pretty much entirely carbon dioxide. This creates a strong greenhouse effect that traps heat on the planet's surface. This is what makes Venus the hottest planet in our solar system, with temperatures going up to a staggering 864 degrees Fahrenheit. The study that we discussed earlier suggests that the lithosphere is responsible for the resurfacing of Venus's outer shell. However, the role that the atmosphere plays in this process is still unclear. It is possible that the extreme heat and pressure created by Venus's atmosphere could be the cause, as it can drive the geological activity that is causing the coronae to form. But that's not all. In addition to looking forwards in time, Venus can also help us understand how Earth reached its present state. According to Smrekar, who is also leading NASA's Veritas mission, Venus also offers a unique opportunity to study Earth's past. She explains that Venus is currently in a state that is expected to occur before a planet forms tectonic plates, and this means that studying Venus can help us better understand what Earth may have looked like over 2.5 billion years ago. This speaks volumes about the potential for future missions to Venus that can study its geological processes in more detail. NASA and other space agencies have sent several missions to Venus in the past, including the Magellan spacecraft that provided the data for this study. But we still barely know anything about the planet, and future missions could help to answer some of these questions. But let's talk more about Veritas. It's an upcoming mission to Venus that's been generating a lot of excitement. Veritas is set to launch in 2028 and will use a suite of instruments to study Venus's geology, including its surface features and interior structure. The mission aims to provide a comprehensive understanding of how Venus's geology has evolved over time and how it is currently shaping the planet's surface. Smrekar explains that the Veritas mission will build on the work of Magellan by providing more accurate and higher resolution data. It's going to use advanced technologies such as synthetic aperture radar and near-infrared spectrometer to create detailed 3D maps of Venus's surface and determine its composition. Apart from all of that, Veritas will also measure Venus's gravitational field to better understand its internal structure and geological processes. According to Smrekar, the mission will act like an orbiting geologist, providing more precise information on active areas and variations in lithospheric thickness. Through this research, Veritas aims to determine if volcanism is responsible for Venus's squishy lithosphere, which allows it to lose heat similar to Earth, or if there are more mysteries yet to be discovered. In addition to the Veritas mission, there are other possible future missions to Venus that could shed more light on the planet's geology and surface features. A mission could be sent to explore the planet's volcanoes, which are thought to be responsible for much of the planet's geologic activity. The mission could study the composition of the rocks and lava on the surface, as well as the gases released by the volcanoes, which could provide clues about the planet's interior. There's also the possibility of discovering signs of microbial life on Venus's clouds. So, a mission that samples the planet's atmosphere could search for signs of organic molecules or other evidence of microbial activity. Overall, there's a huge gap in research on Venus that needs to be filled ASAP. That'll have to do it for NASA revealing that Venus's squishy outer shell is resurfacing.